Good morning, one and all. You are welcome in Sanjeevanee Mahavidyalaya Chapoli in Department of Physics. This lecture belongs to B.Sc TY Physics students, paper number 13A. Second unit, bonding in solids and X-ray diffraction, lecture number 5. In this lecture, we are going to discuss the structure of solid crystals using law method. What is law method? How it is useful? What are the applications? What are the limitations of law method? All these things we discuss in this lecture in detail. Now let's turn to law method. The law method is the oldest method of X-ray diffraction for the study of nature of the crystalline structure. A method of studying crystalline structures by X-ray diffraction, in which finely collimated beam of polychromatic X-ray falls on a single crystal whose orientation can be set as desired, and diffraction of the beam recorded on a photographic film. Law method of X-ray diffraction in analysis of crystal structure. Here single crystal is used. Fixed crystal is irradiated by a beam of continuous spectrum of X-ray. The spots pattern produced is called as X-ray diffraction. X-rays are incident on a single crystal and its spectrum is obtained, called as X-ray diffraction. It gives information about the crystallographic symmetry of the material structure. Its translational vectors A, B, C can be identified. Nature of the structure can be identified by using this method. The law method is mainly used to determine orientation of large single crystals while radiation is reflected from or transmitted through a fixed crystal. The main use of this law method is to determine the orientation of a single crystal. Single crystal is utilized in this method. See here how to determine the crystal structure. This apparatus is shown here, and here on the screen you will get such a dots of the crystal, and from this if we observe this pattern, then we can judge the translational vectors like A, B and C in details. So in this way, with the help of X-ray diffraction method, by using law method, one can easily find the translational vectors of a solid crystal. I will show you one more figure so that you will get an idea how this method is useful for the study of crystal. You see here X-rays are incident on a single crystal is shown in this figure, you see, and these X-rays are diffracted because of the single crystal here, and due to diffraction of X-ray you will get a film. You will get such a dots as per the structure of the crystal on the film. So in transmission law method, the film is placed behind the crystal to record beams which are transmitted through the crystal. In the transmission of law method, the film is placed behind the crystal to record the beams which are transmitted through the crystal, like this. One side of the cone of law reflections is defined by the transmitted beam. The film intersects the cone with the diffraction spots, generally lying on an elliptical shape. Here you see the photograph of law method. Photograph of the structure of the crystal by using law method, we say law photograph. It should be noted that very small separation between the spots. This means very small separation between the spots as shown in this figure. This shows, this means the crystal must be what? Small. The beam must be small and the crystals must be well ordered. From this figure easily you can conclude. Now let's turn towards what type of X-rays are incident on the single crystal. A polychromatic law method was developed for application in flash X-ray diffraction studies. It can also serve as a valuable tool for fast data acquisition with conventional X-ray and synchrotron sources. This present method was developed with a sealed X-ray tube. Its specification is given 45 kilowatt 20 milliampere and a crystal of known structure for calibration of the source spectrum. With the help of this X-ray tube, 45 kilovolt 20 milliampere and a known crystal of the structure, this method was developed. Now, what are the advantages of law method? What are the benefits? What are the advantages of this method we discussed? Actually, it is a very extremely short data collection time. Extremely short data collection time. It means in short time we can collect large data. Second one is time resolved crystallography. Third one is a few exposure covers reciprocal space, especially for high symmetry space groups. Then what are the problems with law method? Unbalanced coverage of reciprocal space. Crystals must withstand intense short exposures or many crystals must be used. Time resolved study used means crystals cannot be frozen, making them vulnerable to X-ray damage. Spatial overlap requires low mosaicity small beam crystals. Uses polychromatic X-rays, generally less than 2 angstrom. Allows data to be collected ultra fast, leading to its application in time resolved crystallography. Still, photographs cover a wide range of reciprocal space. A whole data set may be collected in a few films. Requires synchrotron radiation. So in this way, these are the benefits of using law method. Now, what are the applications of law method? Where this method is applicable? A law method of diffraction is used for determination of orientation of crystals that are large and single. This method is used for the study of orientation of a crystal which is large but single. Next application is that it is the first method used for the diffraction of X-rays. White colored radiations from an X-ray is transmitted or reflected from a crystal by two methods. They are transmission law method and back reflection law method. These two methods were utilized for the study of orientation of crystals. I mean, for the study of orientation of a single crystal. So in this way, we have seen the various uses of law method. Now question arises, what are the advantages of the use of this law method? Then what are the limitations? That part also we have to study. The advantages of using law method of X-ray diffraction are: number one, it is used for checking the orientation of crystals. It is not only used for the checking of orientation of crystals, but also their quality. I mean, quality of the crystals can be checked, and orientation of the crystals also can be checked by using this law method. So this is nothing but one of the advantages of law method. Next one is, it can be used for analyzing specimens that are either thick and large. For the analysis of the specimens which are thick and large, this method is very useful. So this is nothing but another advantage of using law method. Already I have told you, as this method has advantages, then surely it has limitations. Then what are the limitations? It can be used for quantitative analysis. Quantitative analysis as the wavelength of the incident X-ray beam that is causing a specific spot is unknown. Second one is, it also requires large crystal for the analysis. Got it? So this method has limitation, and the second limitation is very important. It requires large crystal for the analysis. So if we think about these two limitations, this method is not suitable. But though it is not suitable, it has some advantages. That advantages we have to take in consideration. Thank you.